Okay, so welcome back. We're ready for the second half of Section 5 of Chapter 1, titled Complex Numbers. This is Part 2. You might want to put that up here next to the title for your notes. We're going to talk specifically today about the number I. The complex, I shouldn't say the number, the imaginary unit, or the complex unit. Now, I to the first power by itself is just I. And we know that from the other day as the square root of -1. Well, if I is square root of -1, what would I squared be? What would I squared be? I squared would just be -1, because it's the square root of -1 times the square root of -1. What would I to the third power be? That's my next question. Well, I to the third power is the same thing as I squared times I. Well, wait a minute. I squared, we already said, is -1 right there. Well, if I squared is -1, then this really just says -1 times I. Well, -1 times I is just -I. Okay, so we found I squared, and I cubed. Let's find I to the fourth power. Well, I to the fourth power would be the same thing as I squared times I squared. Well, that's the same thing as -1 times -1, which happens to be +1. Okay, well, let's keep the pattern going. Let's try I to the fifth power. Well, that would be I to the fourth power times I. Well, that's really just, well, we already did I to the fourth power. That's 1. And 1 times I, well, that's just I. What do you notice here? This cycle has started over. I to the first was I, and so is I to the fifth power. I squared was -1. Guess what? I to the sixth power is also going to be -1. I to the third power was -I. Guess what? I to the seventh power is also going to be -I. I to the fourth power was +1 right there. Guess what? I to the eighth power is also going to be +1. This cycle of the first four numbers, right here, this cycle, it repeats. It's a cyclic process. And here's the cycle. You might want to write this down. Did I spell cycle right? Absolutely not. I didn't. I cannot spell. The cycle goes I, that's to the first power, then -1, then -I, and then +1. And then it just starts back over. Every fourth power, it starts back over. Okay, so that being said, try a few of these. Number 6 is the example we're ready for, Part A. I want you to evaluate I to the 16th power. Now, what you can do is just type that into your calculator. If you have one of those TI-83s or TI-84s, I believe if you hit second, and then I think it's above the 0 is where the I is. I showed you this in the last video. And you just type I to the 16th power, it's going to give you an answer. Now, I to the 16th is the same thing as I to the 4th times I to the 4th times I to the 4th times I to the 4th. Well, what do we say I to the 4th power is? That's really just 1 times 1 times 1 times 1, which is 1. Look at that. Another way you could have written it is I to the 4th power raised to the 4th power, because a power to a power is the product of the powers. Well, that's really just 1 to the 4th power, which is also 1. Try Part B. Part B says I to the 20th power. What would that be? Now, 20 is a multiple of 4. I want you to make that note. That's a multiple of 4. And that's the important part when you're trying to figure out these larger exponents. Any multiple of 4 is always equivalent to I to the 4th power. Well, I to the 4th power was just 1. Sweet. Try Part C. Part C is I to the 21st power. Now, is this a multiple of 4? It's not. It's not a multiple of 4. So we're going to have to figure this one out differently. Well, what you do in these is you take that 20 and you rewrite it so that the nearest multiple of 4 is the first exponent. Well, 20 is a multiple of 4. We just did that. Times I to the first power. Well, I to the 20th power. Since the 20th is a multiple of 4, that's just going to be the same as I to the 4th, which is 1. You're left with 1 times I, and 1 times I is just I. That's the same thing as I to the first power. Remember your cycle? I to the first is just I. I squared is negative 1. I cubed is negative I. And I to the 4th is 1. You're always going to, and then the cycle starts over. You're always going to rewrite your exponent in terms of either the 1, the 2, the 3, or the 4. Every single time. That's what you're going to do. Okay, let's try another one. This is letter C. I to the 22nd power. I to the 22nd power. That's the same thing as I to the 20th, which is a multiple of 4. That's all you care about, times I squared. Well, any multiple of 4 is always just equal to 1, so 1 times I squared. Wait a minute, what's I squared? That's negative 1, so you just put negative 1, and that's your answer. I to the 22nd is the same as I to the 2nd, which is negative 1. Here's another way you can do this stuff. Okay, take the exponent you started with, the 22, put it inside as a dividend, and always divide the dividend by 4. Now, how many times does 4 go into 22? It goes in 5 times with a remainder of 2. And the remainder is always the exponent of interest. Always. So if your remainder had been 3, you'd look at I cubed. If it had been 4, well, then it's just 1. If your remainder had been 1, your answer would be I. Here, let's try another one. Get rid of that stuff. This is letter D. Your quest is to find what I to the 83rd power would be. Okay, well, take a shortcut. Take this 83 and divide it by what? What number do you always divide by? Since the cycle has 4 terms, you divide by 4. 4 goes into 83 20 times with a remainder of 3. So that means, okay, well then I to the 83rd power is the same as I to the 3rd power. That's where it would fall in the cycle if you kept the cycle going. Well, that's just negative I, which you should have memorized. You have to memorize the original cycle. You have to. You have no choice. I is I. I squared negative 1. I cubed negative I. I to the 4th, 1. And then it starts over. Got to have that memorized. Okay, that should be sufficient to get you through that part of the homework. Now I want to talk about something called a complex conjugate. A conjugate, think of opposite. So if you have some expression a plus bi, then you also have the expression a minus bi. And vice versa. If you have a minus bi, you also have a plus bi. So in number 7, part A, you all are going to rationalize this expression. 5 minus 2i over 4 plus 3i. Problem with this expression, you have an imaginary unit in the denominator, and that is not allowed to take place. So you've got to get rid of it by multiplying by its complex conjugate. The conjugate of the denominator, that is. The conjugate of 4 plus 3i is 4 minus 3i. Whatever you do to the bottom, guess what? You got to do to the top. This is really just a big, nasty looking 1. That's all that is. 4 minus 3i over 4 minus 3i is just a stupid 1. It's an ugly one. What this is called rationalizing the denominator. Remember, the reason we had to do this was because why? Because there's an I in the denominator, and that's a big no-no. All right, well, now you have to do your FOIL. You got to do FOIL on top. Do 5 times 4. That's 20. Outers. 5 times negative 3i is negative 15i. Inners. Negative 2i times 4 is negative 8i. Last, negative 2i times negative 3i is plus 6i squared. But you all remember that that really just says what? That really just says minus 6 because I squared is negative 1. On the bottom, do your first. That's 4 times 4 is 16. Outers, minus 12i. Inners, plus 12i. And lasts, minus 9i squared, which again, we can take a shortcut and just write as plus 9. That's what that really says. Well, notice on the bottom, when you did your FOIL, that is F, outers, inners, lasts, the outers and the inners cancel. And that's the point. And in fact, whenever you're doing these problems, don't even worry about doing the outers and the inners. Don't even really worry about doing the oi, as I call it, because they're always going to cancel. All right, so the numerator, combine your 20 and your minus 6, that's 14. Combine negative 15i and negative 8i, that's minus 23i. All over, the bottom says 16 plus 9, that's really 25. If you can reduce, reduce. Otherwise, split your answer apart and leave it in this form. This is the A plus BI form that we've talked about before. There you go. That's your answer. Now, if you can reduce either one of those fractions, then you should reduce those. So 14 25ths minus 23 25ths I is what this looks like when it's simplified. All right, let's try one a little bit saucier. So I'm going to get rid of this, and we're going to do, let's call this part B now, part B. Here it is, 2 plus I square root 5 all over 3 minus I square root 5. Rationalize that fraction. I'm going to do this one with you, and I'm going to give you one to do on your own. The conjugate of the denominator is 3 plus I root 5. Do that to the top and the bottom. Do FOIL on top. 2 times 3 is 6. Outers is 2i root 5. Inners is 3i root 5. And lasts, I times I is I squared. Root 5 times root 5 is just 5. So I squared and 5 make negative 5. Ask yourself if you just followed what I did. I squared is negative 1 times 5. On the bottom, all we need to do are firsts, 9, and lasts, because the outers and inners cancel. So that would be minus I squared times 5. Well, minus I squared becomes plus 1. Two negatives make a positive. Times 5 is plus 5. Combine like terms on the top. 6 minus 5 is 1. 2 plus 3 is 5. Leave the 5 inside the root because it doesn't change. It doesn't add. The bottom's 14. And guess what? You are done. But let's clean this up a bit. Leave it in the right format. 1/14 plus 5 root 5 over 14i. And there you go. As long as it's reduced, which this one is, you're done. That's all you can do. I'm going to give you all one to try. And you're going to try it on your own and see how you do. Call this letter C. Letter C. You are going to do 4 plus I root 3 divided by 5 minus I root 3. That's what you're going to do. All right? Your answer should end up being 17/28 plus 9 root 3 28 I. That's a 17 there. 17/28 plus 9 root 3 28 I. That's what you should get. If not, you did something wrong. And if you still can't figure it out after checking it again, then come and ask me tomorrow in class. Okay, just a few more examples here. I would like for you all to rewrite I to the 49th power. What is I to the 49th power? Well, remember, what you're interested in is the nearest multiple of 4. So it may help you to do 49 divided by 4. That's 12, remainder 1. So therefore, I to the 49th power is the same thing as just I to the first power, which is just I. Well, that's easy enough. That's nothing different than what we've already done. But try this one. I to the negative 10th power. Oh, doggy. Now, you haven't seen a negative exponent yet this year, but you should remember from Algebra 2 that a negative exponent means you send it to the denominator. Let me erase that because that's wrong how I had written that. A negative exponent means that technically I to the 10th is in the denominator. And now he's happy. You can never have negative exponents. And now you work it the same way you did earlier. So take your 10, divided by your 4. That's 2, remainder 2. So this is the same thing as 1 over I squared, because that's your remainder. Well, I squared is negative 1. Answer, 1 over negative 1 is just negative 1. Again, check these in your calculator. Type them into your calculator. Okay, letter C. This ought to be a good one. I to the negative 3rd power. Well, again, he's not happy in the numerator. Send him to the denominator. So you have 1 over I cubed. Well, that's one that you should have memorized. That's in your cycle. I cubed is just negative I. Now, are you done? Yes or no? Uh-oh. You're not done. Because you have an I in the denominator. Now, remember, this is really A plus BI down here. That means this is really 1 over 0 minus I. A here is 0. What's the conjugate of 0 minus I? Well, it's 0 plus I. So do that on the top and the bottom to get rid of I in the denominator. On the top, 1 times 0 plus I is just I. On the bottom, 0 times 0 goes away. Outers and inners go away. But negative I times I is negative I squared. Excuse me. Negative I squared is the opposite of negative 1, which is really just positive 1. Therefore, that is just I. Cool. You could have also worked your way backwards and gotten there. All right, you guys try one. Here it is. Letter D. I to the negative 39th power. I to the negative 39th power. Your answer should end up being, when you're done, should just be plain old I. But you got to show me that. You can't just say I. You can't just type it into your calculator. You have to show me that it ends up being I. Remember, move it to the denominator. Divide by 4 to figure out which exponent you're really working with. I squared, I cubed, or I fourth. And then rationalize it to get the I out of the denominator. Should get I. Let me know if you have questions. Last slide, right here. Last example. Find real numbers. That means numbers without i's. Such that find real numbers x and y such that this statement right here is true. Okay? Well, this whole big 3x plus y, that's just like a. This 4 minus 9x, that's just like b. That's your coefficient of I. Over here, a is 1, and over here, b is negative 5. Well, what you do, it's really very simple. You set your real parts equal. Your real parts are always the a's, the parts without the I. So you have 3x plus y is equal to 1. Well, that's pretty simple. You know that a is equal to a. That's why we were allowed to do that. Over here, we're going to do our complex parts. In other words, we're going to set our b equal to our b. Well, b on the left side was 4 minus 9x. B on the right side was negative 5. Which one of these sides could we solve for one variable right now? Well, the right side only has one variable, x. So solve for that. Let's see here. Negative 9x is equal to negative 9. Oh, so x must equal 1. Well, that's cool. And now that I know x, guess what? I can plop it in over there, and I can find y. So this is really just says 3 plus y is 1, therefore y is negative 2. Now what happens on these sometimes is both the real and the complex parts will have multiple variables, x and y, in which case you simply use either elimination or substitution, whichever works out easiest in order to solve it. Well, that's all I have for Section 5. I hope you enjoyed it. I hope you're as happy as Jake was in the second picture that I showed you. Have a great evening. I will catch you later. I'm out.